Hello everyone, this is our tutorial about Chapter 7's subjects, percent comp, and empirical and molecular formulas.
So what is percent composition?
Percent composition is the percentages of elements and compounds. All compounds have a specific percent comp for all samples, regardless of size.
Our first problem is the percent composition of lead-2 chloride.
First, we need to find the molar mass of lead-2 chloride.
The molar mass is the total mass of a compound.
Multiply the amount of moles of the element times the AMU of the element over 1 mole.
One mole of lead times 207.2 over 1 mole and 2 moles of chlorine times 35.45 over 1 mole.
And then add both of these answers together and get 278.1 grams per mole of lead-2 chloride.
Once you have the molar mass, you divide your molar mass of lead and chloride by the total molar mass.
And then you multiply both of these answers times 100, and you are left with your percent composition. And remember, sig figs are not necessary for percent composition.
Now on to our next problem. In 261.35 grams per mole of barium nitrate, what percent of it is barium, nitrogen, and oxygen?
This time, we are going to let you try it yourselves before we give you the answer.
Pause the video now.
First, find the mass of barium, 2 atoms of nitrogen, 6 atoms of oxygen.
You should get the answer of barium 137.33, nitrogen 28.02, and oxygen 96.
Then divide those answers by the total molar mass that was given at the beginning of the problem.
Multiply those answers by 100 to get your percentages.
It's just that simple.
And to check your answer, you should add up all your percentages and you get 100.
Now we will move on to empirical and molecular formulas.
The empirical formula is the simplest whole number ratio of a compound.
The molecular formula is the actual ratio of a compound.
Ionic compounds are always written in empirical formulas.
Covalent can be written in both molecular and empirical forms.
Two different covalent compounds can have the same empirical formula, but can have different molecular formulas,
thus making two compounds made of the same elements but have different properties and uses.
First, we will find the empirical formula from percent comp.
If we have 28.4% of copper and 71.6% of bromine, what is the empirical formula?
First, you take the percentages times 1 mole over the mass of the element.
You should end up with a decimal.
Convert that decimal into a ratio that becomes the ratio between each of the elements.
In this case, the ratio is 1 copper to 2 bromine.
The answer is CuBr2.
Now we will determine the empirical formula for 100 grams of carbon and hydrogen. In 100 grams of CH, there is 85.6% carbon, 14.4% hydrogen. The first step is to multiply 85.6 by 1 mole over 12.01 AMU. You should get 7.127. Next, you multiply 14.4 by 1 mole over 1.01 AMU. You should get 14.257. Compare the two answers and get a ratio of 2 to 1. The answer is CH2. Now we'll take our answer from the previous question and figure out the molecular formula for CH2 that has a molar mass of 28 grams per mole. First, get the AMU for carbon and hydrogen 2. Take those numbers and add them to get the molar mass. Then compare the molar mass to the original 28 grams per mole. How many times the molar mass goes into 28 is how much you will times your subscripts by. So 14.03 goes into 28 roughly 2 times. So you would multiply all the subscripts by 2 and get an answer of C2H4. Empirical and molecular formulas can actually be used in forensic labs like in CSI. The labs use percentages to figure out what types of compounds, drugs, or poisons is used. Thanks for watching.